right, good morning. We are going to dive into chapter 2 by way of just an announcement. The book is finally available to order, so the long ordeal of getting it onto Amazon is over. All right. So, and I hope I didn't do too much last time in terms of preparing you for chapter 2. I mean, it's not that it's a bad chapter. It's super valuable for almost everybody, but it is a lot of syntax. You know, in a normal chapter, we learn a little syntax and then some more UI stuff, and we do that kind of step by step. But chapter 2 is this big, high-level overview of what it's going to be like to program in Lua. And I think maybe an analogy would be helpful here. It's sort of like if you're visiting maybe Hawaii and you haven't been there and you take a helicopter tour to get a lay of the whole land. You see the waterfalls and the rainforest and the volcanic areas and the beaches and shopping districts and whatever else you see. But just having done the helicopter tour, you haven't really done any of the stuff you saw. You just got a feeling for where it is. And that's sort of what this chapter is like. It's sort of like your helicopter tour of coding in Lua and Solar2D. The material, what is programming? So I know for some of you, this will be just review, and others, I know it's newer stuff. So what is programming? Programming is just the art and science of telling a computer what to do. We tell a computer what to do by writing it a set of instructions. They have to be very detailed. The computers aren't, good at interpreting or guessing or intuiting what you want them to do. Rather, you have to tell them exactly what you want them to do, step by step, in order. There are lots and lots of programming languages. Unfortunately, at this point, English is not one of the programming languages. That maybe we're heading that way. I don't know how soon we get there, but right now, you have to use a language that has been designed for telling computers what to do. There are certainly hundreds of different programming languages. And I've got 3 examples here, although one's really just for fun. But you can see Lua, you can see that the table has 3 different languages and 3 different Hello World apps or code programs. So Lua just says print hello world, which we did last time, super easy. Java in the middle says public class hello, public static void main, system out print line hello world. It does the same thing as the Lua statement does. It's just more complex because Java is a more complex language. It's a general purpose, object-oriented programming language. Lua is what is typically referred to as a scripting language. So it doesn't have tens of thousands of commands. Lua can't do as much as Java, but what it does do, it's going to make easier syntactically to get it done, clearer and easier. Not that Java is bad. I use the same table in the Java class to show them kind of where Java fits on the hierarchy. Of course, in Java, I would emphasize that Java does so much more. But then I wanted something that was more complex to compare and contrast. That's Malboj, the last cell in the table. So if you haven't heard of Malboj, it is a programming language that was developed with the specific intent of making it impossible to do anything useful with it. So it's sort of a computer science thought exercise or a computer science version of self-harm. I don't know. It's the whole thing's weird as an idea. And it took years to figure out how to code Hello World. So that is actually the Hello World program in Malboj. It's just ridiculous how difficult it is to figure out how to make it do anything. So we're not doing Malboj. That may disappoint some of you, but there is no textbook for it. So we are obviously focusing on Lua, and what I would emphasize about Lua is Look how clear it is. Look how, straightforward it is. That's good news because as a simpler scripting language, there's not as much complexity to have to worry about learning and mastering. So programming involves telling a computer what to do, but it's more than that. You also have to supply the computer with input, typically data of some sort, numbers or text or audio or video or whatever makes sense for the program you're programming. The step-by-step instructions form what you would call the process or the procedure of how the program takes inputs and produces desired outputs. So there's two big analogies that the most textbooks use. One is it's a lot like a recipe. I don't know if any of you guys cook or like to cook, but a recipe would have ingredients, which are inputs, and a step-by-step process to take those ingredients and work with them and move them towards some sort of desired output, food output. And then the desired food output is the output. So that's analogous to telling a computer to take these numbers and perform this math on the numbers and then produce a report with those results. The other way most computer science textbooks look at it is the programs are a system. They have inputs, they have process, they have outputs. So a program is itself a simple system. I try to use in the keynotes a color coding system. And we haven't defined all of these things yet, but just in the back of your mind, know that there are colors that I am using to try to be consistent about highlighting different coding features with different colors. Once you get used to the colors, it in theory at least, makes it easier to glance at code and figure out or pick up on what's going on, more easily. Purple I use for what we're going to call literal values, which are actual raw data like numbers. Variables will be orange, tables will be green, and functions will be light blue, except obviously where I've overlooked the coloring. All right. So I think I just said this actually, but input can be various types of data, numbers, Boolean values, true or false, logical, data that's been structured into some sort of table or array, or reading in objects or table-based data. All of that could be stuff that you can feed into, you're going to acquire for your program and then work with. So I'm using two different terms here when I talk about data. One is literal, the other is variable. So the difference is literals are numbers, are values, are text, and variables are storage spots for data, for literals. So all languages use variables to do this. And even if you haven't done this before, if you've done any work with spreadsheets, essentially a spreadsheet is a visible grid of data / procedure cells. And you can use spreadsheet data in cells as if it were variable names just by giving the cell name. You guys know how to do that. And I know some of you will have programmed and have some experience with it. All languages have some variable naming rules that you have to follow. Lua is really straightforward. Variable names, or more broadly, what's called identifiers, that you would use to name a variable or name a function or name a table, have to be made of letters and numbers, and they may use the underscore symbol. And then the only restriction is they can't start with a number, which is pretty typical. So it's similar to Java. It's similar to other languages. It's a little slightly more restrictive than Java, but not much. Importantly, you can't have any other symbols. So for instance, if you're used to using the $ or the string symbol, you can't do that in Lua Solar2D. And any other symbol you might see on your keyboard, you cannot use as part of a valid Lua variable name identifier. And also things you can't necessarily see on the keyboard, like spaces. You can't have any spaces in in variable names. Spaces will trip up the interpreter. When it hits a space, it thinks it's moving to the next part of an expression that it's evaluating. So no spaces, no symbols other than the underscore. Also, you can't use reserved keywords, just like in other languages. You can't call a variable for or while or do. Any word that is part of the language is off limits for your use as a variable name or identifier. So just as a quick, just sort of self-study, look at this list and just think through, do you feel like these are valid? Are there any that give you pause for, concern? Let me give you a second to look over it and then we'll talk through it. All right, so let's just start in the top left there. First payment. Do you guys see anything there that gives you pause? I mean, it's all letters. There's no space. There's no symbols at all. So, and it doesn't start with a number. So yeah, you're good to go. What about that second one, last payment? I used to do that in a font that you couldn't tell, so the one looked like an L, but I decided that was kind of pointlessly mean, but yeah, the one stands out there in that font, and you can use a one in a variable name. You just can't use it as the first character of the variable name or function name. So same thing with second payment. What about bottle condition with the underscore? So the only restriction for Lua in terms of start is it can't start with a number. And the underscore is one of the one and only symbol that we can use. So therefore, underscore works fine as part of an identifier. And I sometimes use the underscore in the first spot there to store logical data, true or false data. Sort of reminds me of like something on a checklist that I would check or uncheck, which is essentially what Boolean variables do. All right, hops with the square brackets. So the square brackets will be used as part of accessing data in Lua tables. But to do that, you'd have to have an index number in there. For that to be a valid identifier to point at data in a table, it would have to be something like hops 0 or hops 1 or hops 10 or whatever the case may be. So without a number, an integer index number in there, that's not an identifier. Okay, T, there's nothing wrong with it. Single letter variable names are actually pretty common. We'll use those a lot. Certainly they'll be used as integer index numbers frequently for tables and other things. So T's great. Local T, although I did say you can't use reserved keywords, and local would be a reserved keyword. The identifier is actually local and then 2 more characters. So local underscore T is not a reserved keyword. So you can include words like for and do and while and local and others that are reserved, as long as that isn't the entirety of the identifier. So if you skip down to while, that's not a valid identifier because while is a reserved keyword and I haven't added anything to it to make it essentially not while. Customer name. So that'd be a really common identifier in a lot of languages. It's not going to fly in Lua because the $ is not a usable symbol. Average days in month is perfectly fine. Nothing wrong with that. You'll notice the capitalization starts with a lowercase letter and then capitalizes the letter in each successive word. That's a style that's called camel case. And it's pretty commonly used in programming. The other option in terms of writing that kind of a variable with sort of a compound word in it is to use underscores to separate each of the words. And some people find that approach easier to read. So that's a style issue. Next one, total days in year. Again, you've got to notice that there's a space in there. If you pick up that there's a space in there, then that makes it not a valid identifier. Because again, the Lua interpreter, whichever one it is, will read in the word total and think that's a variable of some sort. When it hits that space, and it thinks you're done naming that variable, and total is not a valid. Total by itself would be a good identifier. Total days in year with a space in the middle of it is not. Days in year by itself would be a perfectly good identifier, but trying to combine those two with a space will not fly. And then sequence 4, so the quotes are the issue, right? By putting quotes around sequence 4, instead of being a variable sequence 4, it's a piece of text. The quotes tell the Lua interpreter to look at that as a literal text value, like hello world. So it's a perfectly good literal text value. You can't use literal text values as identifiers. If you took off the quotes, you'd be fine. In terms of drawing a code, obviously drawing a code creates a lot of variables for you. When you select any of those script objects and add it to drawing a code, you'll see it generates a lot of code. And one part of the code that it generates is a valid identifier for what you just created. So for instance, if you put a circle on screen, it creates a circle display object and names it. And so in drawing a code, I use 3 letters, OBJ, short for object, and then a number. So the first thing you add to your drawn a code script stack will get named OBJ1 or object1. And then I'd simply keep counting up. So every time you add something else to your script stack, it gets a new object identifier, which is in the form of OBJ and then the number that you're at. In drawn a code, I do have some objects that you can name. You can also create a display group and give it a name. And that group name will then actually be used in place of the OBJ identifier. All right, case sensitivity. So this is the slide that's been up for several minutes while I talked about something else. But yeah, Lua is case sensitive. And I know some of you know Java and some of you have programmed in other languages that are case sensitive. The difference to some extent is that Lua is super flexible. That'll be a theme we'll run into several times in terms of coding, is that Lua will try to work with whatever you type. If you use an identifier and capitalize it differently and don't notice it, what Lua does is it says, you must be creating a new variable. So if you, for instance, typed cups of sugar as part of a recipe and used the lowercase letter to start with, and then later in your code, you tried to do something with cups of sugar, but you capitalized that C, in general, Lua is okay with that, but they're not the same variable. Those are 2 different variables. So if you stored 3, say, as cups of sugar, and then later you try to do something with cups of sugar with a different capitalization, there's no value in that second cups of sugar. So you'll run into trouble, even though Lua is trying to make it work. In general, it won't work in terms of what you want to have happen. I mean, long story short, all languages are really going to be picky about your spelling, consistently spelling variable names, consistently capitalizing them, and just being careful about that and aware about that. Obviously, in drawing a code, I take care of that by naming everything that you add using that system, so that won't trip you up, at least for the stuff that you create in drawing a code. So you might be thinking, well, if drawing a code creates all these variables, why do I need to know? And you said drawing a code follows the rules, then why do I need to know the rules? And the answer is, you'll still need to be able to create variables and work with them. Even one of the most simple things that we do very early on to program is something like a counter, which it might have a button, and when you press the button, it counts and counts up. Well, drawing a code won't create that counter variable for you. You'll have to create a counter variable and start at a 0 or 1 or whatever you want to start with. And then you'll write a little bit of script inside the button of that handler that adds 1 to that variable. So to do something like that, drawing a code will take care of all of the code with respect to coding the button. So you'll still need to be able to create basic variables of your own and then use them later in the code. And to do that, you have to know the variable naming rules. When I create my own variables, and we'll do a lot of this and follow along, I always name it something descriptive. So if I'm creating a counter, I typically would call it counter. Why would I call it obj20? That doesn't really make any sense. When I had the power and discretion to name my own variable or name my own function, I'm going to call it something that reminds me what the purpose of the variable is. Okay, so the other thing we have to think about in programming is data types. The thing about Lua is, again, the theme is it's really flexible. Unlike Java, where you have to tell Java what the data type is before you even try to work with it, in Lua, you never tell it what the data type is. It just assumes what the data type or infers what the data type is based on how you're using it. So you'll see when we get to it in terms of just creating a variable and assigning data to it, there's no data type. And there are nice things about that. The problem is, it's not a problem really, but the downside is in a language that is strictly typed and knows what the data type should be that you try to put into a variable, the advantage of the strictly typed language is that it will stop you from doing the wrong thing. It will stop you from trying to put, for instance, a piece of text into a variable that you're trying to put a number in. Lua will just roll with it. If you create a variable and put a number in it, and then later in the code use it and put some text in it, in general, Lua just says, all right, we'll move on now with this as text data. So there's pros and cons. Strictly typed languages are a pain in some ways and make you think through data types carefully, and non-strictly typed languages don't. And sometimes it'll be really fun and cool and it makes the syntax easier. But then every once in a while, you'll do something accidentally, switching up a data type that you don't mean to, and then your code, doesn't necessarily work the way you think it should. Okay, so I think I already said this, but literal values are actual raw data, a number, a true or a false, a piece of text, a piece of literal text like hello that's in quotes, or sequence 4 that's in quotes, or hello world that's in quotes. These are literal values or actual data values. Variables are named spaces to store literal values. Once again, high-level overview. We are covering a lot of slides with a lot of content, but we will come back to each of these and have examples and activities. And obviously there's homework in the book to help you think through aspects of all of this. Lua tables are what's referred to as a data structure. So tables allow you to create a named spot to store and organize related data. So tables are something like arrays, if you've coded in language that have arrays. But the interesting thing in Lua is that the table is the only data structure. So if you did take Java or you've taken a language with different data structures, one of the first things you have to think through is, once you realize, hey, I need to store a list of my students or a list of my customers or a list of items in the purchase order. In a language with lots of flexible data types, the first question then is, well, how do I store that? Should that be an array? Should it be an array list? Should it be in some sort of hashing structure? Should it be in some sort of collection? What is the data structure that I want to use based on how I'm going to work with this data? In Lua, once you realize you need a data structure, your choice is, do I use a table? Or do I not use a data structure because table's it? Certainly in one sense that simplifies matters quite a bit because there's no there's no choice. This may seem, very limiting. Wait a minute. What if I, you know, what if I need to do X, Y, or Z with the data structure? Does a table support that? And in some ways, probably it won't, but that's a simplification for scripting languages. But I will say tables in Lua are very flexible. They work with a few different syntaxes. And not only can you store literal values in tables, and you could store variable data in it as well. You can also store tables within tables. And you can store, this is kind of the kicker, you can store functions inside of tables. So tables are super flexible in Lua to a really impressive degree. If you are thinking, oh, I wish there was more, I can't believe there's just one data structure, I would just say, dig into the Lua table and see what it can do. Okay, so I said we get to the point where I showed you the syntax for using variables. And so here we are. I create 4 variables there and then a table. So here are the 4 variables. Here's the table. The variables are each of the classic data types in programming. One is a string, hello. One is a Boolean true or false. One is an integer number, 27. And one is a decimal or floating point number of 1.618. So if you're looking at that with only experience in a strictly typed language, it's a little bit jarring because you'll realize there's no data types. We simply said, for instance, golden ratio equals 1.618. I didn't say that's a floating point number. I didn't tell it what precision to store it in. Lua just looks at what we're doing here and infers that it has a decimal place, so it's a floating point number, so we will proceed with it as a floating point number. And if I later try to store an integer in it, not an issue. There's no data type mismatch issues because data types are not strictly enforced. And then the table. So here's 2 possible syntaxes with tables. The first is I can create a table and pass it actual data values separated by commas inside of these curly braces. So that would create an array called hop list with 2 pieces of text in it, Cascade and Southern Star. The other way you can use the Lua table is with these square brackets. What you've done is said, here's a table, here's the first data element in the table, and it is this value, Cascade. Here's the second data item, and it is this value, Southern Star. So both of those syntaxes are valid. The first one simply doesn't explicitly say what the index numbers are, and the second syntax explicitly says what the index numbers are. I will say also, if you're coming from another language, Lua starts table indexes at 1, not at 0. So most other languages start at 0. So if you've gotten used to that from other languages, that would be a caution. If this is your first language, then forget I just said that. 1's a great place to start. In some ways, it makes more sense than 0. All right, and just again, another caveat for object-oriented programmers, if you have experience with any object-oriented language, Lua is not object-oriented. But interestingly, it is frequently possible to use tables to some extent as what you might think of as objects. Because I said, if you remember, I said tables can store data and functions. And an object in an object-oriented language is data and functions, but they're called methods. I mean, there's more to object orientation, certainly, but we can frequently code Lua in a manner that is somewhat similar to object-oriented languages. So if you've already gotten comfortable with creating something like maybe a customer and putting name and address and stuff in it, and then also putting in methods that do something with customer objects, like add a new order or return a product or whatever you might code as a as a method in an object-oriented language, you can code as a function and put it into Lua Tables. If again, this is your first language, your first major language, then that may not make any sense, but just know that the tables are super flexible and can do stuff that's more sophisticated maybe than you might expect in a simple scripting language. And the example here is I'm creating a table called student. I'm putting in an integer number, a student ID number, and then I'm putting in a function that is called getGPA. And getGPA will return, I've hard coded it just to return a 4.0. So I can then use that table in a manner that is very reminiscent of object-oriented program. I can reach into the table and pull out the student's name, and I can grab their GPA by calling the getGPA function on the student table. So the syntax ends up looking quite a bit like an object-oriented language, even though, strictly speaking, it is not. Okay. I feel like I have used a bunch of terms without necessarily giving you a definition of each. Specifically, literal, variable, operator, expression, and statement are the key things that you'll want to be comfortable with as ideas. So literal is an actual value of a data type, like an actual number, an actual piece of text, an actual true or false. A variable is a named entity for storing a value that you can change. You can assign literal values to it. You can assign the result of mathematic operations to it, and so on and so forth. Operator is a symbol that we'll use to represent some action, to tell Lua to take some action. An example would be multiplying two numbers. There's a symbol for multiplication. It's the same symbol in other languages. It's the same symbol in spreadsheets, the asterisks. An expression is just a valid combination of literals, variables, and operators. So it is something that the computer, that Lua can look at and evaluate. For instance, 2 plus 2. That's a valid expression. Lua can look at 2 plus 2 and say, I can process this. I can take the next step with this. I can add 2 and 2 and make it 4 and then move forward with 4 as the result of that evaluation. If Lua can do that, that's a valid expression. A statement is a complete, valid instruction. So it is, some people would think of it as a line of code, a complete line of code. Technically, there are lines of codes that aren't statements. So I don't love that necessarily, but at the same time, 90% of our statements will be lines of code, single lines of code. So a statement is an entire chunk or piece of code that the computer can evaluate, can get a result, can do something with the result, and then can move on to the next statement. The main operators are the same as most other languages. Operators will be used as part of building mathematic expressions. So an example, if these terms seem like there's a lot of overlap or lack of clarity in your mind on them, let's just think through a simple example. And here I've color coded it, like I said, so the literals are purple, variables are orange, and the formula or the expression, I'm trying to use gold, but not very effectively here. So if we had a number, a literal number, let's say 5, and we needed to store it, we could store it in a variable. I've called the variable here weight in kilograms or weight in kg. So I've stored the literal 5 in the variable weight in kg. So the little table here tells you at each step what the values are. There are 2 variables I'm using here, weight in kg and weight in pounds or lbs. So all the expression is doing is trying to convert kilograms to pounds by multiplying by 2.2. Not a complex expression, certainly. When the statement starts out, there's nothing in the 2 variables, so their value is nil. And nil in Lua means nothing. It doesn't mean nothing, it means something, but the something that it means is nothing. Just like null in Java, it literally means there's nothing in this yet. And you can run into issues with attempting to access data which is nil. You'll get an error like that if you try to do something with a variable that has no data in it. So just be aware that if you see nil in an error message, that's what it means is you need to start out with an assignment that puts data in it before you try to do something with it. So this is step 2 is I'm putting the literal into a variable. So at this point, weight in kg has the value 5. If you look at weight in pounds, it starts out with the variable nil. After step 2, it still has a variable nil in it because we haven't done anything with weight in pounds. We do something with weight in pounds finally in the 3rd step. We multiply weight in kg by 2.2, the result's 11. So weight in pounds will have the value of 11 after the formula is executed. Weight in kg still has the value 5 because the formula doesn't change the value in weight in kg. All right. A little more visually maybe, you can think of a program as a stack of statements. So every program will be a sequence of statements executed in order. What's the order? So the order is typically top to bottom. So it is literally like a list of, which hand to use is easier, list of statements one after the other that will be executed in the order that you would probably read them from the top of the list down to the bottom. There are complexities that are added to that where the flow of execution might jump. If you call the function, it would jump to the function and then jump back. If the user did something like pressed a button, then the flow of execution will jump from whatever you're doing into the code that handles the button press and then jump back. So the simple top-down is just the rule, but there are exceptions. But so if we look at the last example as a sequence, we would say the first step is we're putting the value 5 in the variable weight in kg. In the second statement, we're doing the math to perform the calculation or the conversion that we need. And then in step 3, I'm using a print statement here just to display the result to the console. This is not an exciting program, but it is a program that would run and spit out to the console weight in pounds equals 11. When we think about programming, we start to think about how do I break what I want to do into smaller steps, and how do I get to the point where each of the steps can be represented with statements I know I can write. As soon as you can see a program like that and realize I can break that down into things I can do, you've done all the work almost in terms of programming. I mean, I always say programming is, people tend to think it's all about syntax and how do I get the right syntax and what operator do I use and what's the sequence I need to do in this statement, or how do I order these expressions. Programming is much more about thinking. It's much more about looking at a complex problem and breaking it into smaller pieces that I can then represent as sequences of instructions. As soon as you realize you know how to break a problem apart, you've done all the hard work. You can always find the syntax, almost always find the syntax. You look it up, read it, experiment with different syntaxes. The syntax frequently is the easiest part, especially if you've thought clearly about the problem and how to break it down. All right, so this is my second attempt at just visually trying to help you think through what the terms mean, and what kind of the basics of writing statements is. So if I wanted to do a slightly more complex math expression, you can see I'm doing the multiplication twice on 2 different variables, and then I'm adding the result together, and then I'm storing it into a new variable called pounds of DME. Here's that same exact statement, but it's been colorized using the colors we talked about. So you can see the 3 variables in it are orange. The 2 literal values in it are purple. 2.2s are literal. The operators are gray. The expression is underlined in sort of a gold. Is that what you call that? It's goldish, I guess. Bronze, I don't know. So everything to the right of that equal sign is an expression. And by that, I mean it is a chunk of code, a piece of code, a block of code, a segment of code that Lua can evaluate. It can do that math and come up with a result. That makes it a valid expression, which can be evaluated, and then the result of the evaluation gets assigned into the variable on the left-hand side of the equal sign. So just like in regular math, we look at what is the formula that we have to solve first, and then once we have that solution, we can use it and plug it into something else. Same thing in writing a statement in a computer. As you think through what's on the left-hand side, what's on the right-hand side, how do I get the result I want, and then how do I work with the result once I've found it? That's kind of the foundation of lots and lots of expressions. The other thing that you'll want to start building an understanding of, hopefully you already have some of it, and this is kind of intuitive just from years of doing math and maybe using spreadsheets even, but the thing you have to think through is, what's the order of execution? When Java, not Java, when Lua looks at a statement, well, Java too, but that's not what we're talking about. When Lua looks at a statement, it can't execute it all simultaneously. It has to pick and choose, how do I evaluate the different pieces of this statement, and what is the order that I need to use? First rule is the right-hand side of the equal sign rule. Everything on the right-hand side of the equal sign is evaluated first before anything on the left-hand side is considered. That makes sense. You can't assign the result into pounds of DME, the red variable, until you have a result to assign into pounds of DME, right? I mean, it wouldn't make sense to think that somehow we could do that assignment first and then do the math later. You do the math first, get a result, and then finally do the assignment. So right-hand side of the equal sign is always first, and then it's processed by default from left to right. So the first thing that's executed in this statement is that first green multiplication. And then mathematic precedence is applied, and multiplication is of higher precedence than addition. So the flow of execution jumps to the gold colored part of the expression, which is the second multiplication. The third step in the flow of execution then is the addition. There's no more math to do, and the addition now has precedence, so the addition is carried out. At that point, we have a valid solution, a valid evaluation of the expression. So then finally the assignment can be carried out. The number, the result, is stored into pounds of DME. And then the fifth step, if you want to think of it that way, would be moving to the next statement. After the assignment's completed, the work of that statement is done. It is complete, and the computer can move on to the next instruction. All right, the other set of operators are what's called Boolean operators. These are named after a man named Boole, who I never know whether to say he invented logical math or he discovered it or what, but he's the one who came up with and codified a set of symbols to use that could then be used to describe how you evaluate whether something is true or something is false. These are slightly different than other languages potentially that you know. The equality operator is the double equal sign. So if you want to ask logically, are two things equal, you do that using two equal signs. If you want to look for non-equality, the operator is the tilde in the equal sign. So tilde equals put together like that means is not equal. So if you wanted to do a sort of test where you're saying, are these things not equal? And if so, this is what I want to do, or this is what I don't want to do. That's the operator. The other ones are really standard, greater than or equal to, less than or equal to, greater than, less than, all use the typical symbology here. Nicely, Lua uses the words and, or, and not instead of symbols. All right, I'm going to stop here.